Hello everyone and welcome back. So in our last lecture we learned what is divergence of a vector function and its physical significance. So in this particular lecture we will do some applications or problems based on divergence of a vector function. Now let us see the first example. See here one vector function f bar is given. What we have to find? We have to find nebula dot f bar means divergence of f bar at a particular point 1, -1 and then 1. So let us find nebula dot f bar. So what is nebula? It's nothing but I del del x, j del del y plus k del del z dot and then f bar. F bar is x, y square, I cap. So if you write cap, then in each and every time you use cap, otherwise you can skip it. Plus 2x square y z j and then 3y z square. Okay. Now dot product is very simple. I dot I is 1. Similarly j dot j is 1 and then k dot k is 1. So what we will get? Del del x of x y square plus del del y of 2x square yz and then minus del del z of 3y z square. Now we have to simple partial differentiate it. So with respect to x, so differentiation of x is 1, so we have only y square, and here we are differentiating with respect to y, so here there is one y, so derivative of y is 1 and other terms will remain same, and then finally derivative of z, so it's minus 3y into differentiation of z square is how much? Twice z. Now we have to find nebula dot f bar means divergence of f bar at which point? 1, -1 and then 1. So if we put -1 here, it will be plus 1 minus 1 square, and then if we put 1 and 1, it will get 2, and then here if we put -1, how much it is? It is 6. So final answer is how much? 9. Similarly, if you do example number 2, the same way, suppose r bar is equals to how much? X I cap plus y j cap plus how much? Z k cap. The nebula dot r bar, so is how much? I del del x plus j del del y plus k del del z dot x I cap y j cap plus z k cap. So it's a simple dot product. So I dot I is again 1. So what we have? We have del del x of x, del del x of x, 1 minute, okay, plus del del y of y, and then what? Del del z of z. So derivative of x is how much? 1. Differentiation of y is also 1 and derivative of z is also 1. So this problem is very, very simple. Now let us take another problem. Phi of phi is equals to how much? Phi equals to log of x square plus y square plus z square. We have to find divergence of what? Gradient phi. So before finding divergence of gradient phi, we need to find grade phi. Okay, so grade phi. So gradient is what? Nebula phi. Phi is what? Log of x square plus y square plus z square. So nebula is what? I del del x plus j del del y plus k del del z. Okay, then what is phi? Phi is our log of x square plus y square plus z square. Now we have to simple differentiate it. Suppose I into what you have to write? Del del x. Okay, del del x of this and del del x of log of x square plus y square plus z square plus j del del y of log x square plus y square plus z square, and then similarly k into del del z of log x square plus y square plus z square. Now it's a simple differentiation. So ddx of log x is how much? 1 by x plus y square plus z square, and then again by chain rule we have to differentiate this with respect to x. So derivative of x square is how much? Twice x. Similarly, j is into, it will be how much? Twice y divided by x square plus y square plus z square, and then k into twice z divided by x square plus y square plus z square. So this is our gradient phi. Now what we have to find? We have to find the divergence of this particular grade phi. So divergence of grade phi. So divergence means what? Nebula dot grade phi. Okay, grade phi is our nebula phi. So this nebula is I del del x plus j del del y plus k del del z dot. So nebula phi means grade phi. Just now we got it. So it's I twice x divided by x square plus y square plus z square plus j twice y by x square plus y square plus z square, and then k twice z by x square plus y square plus z square. Okay, now we have to find the dot product. So dot means again same, I dot I is 1. So what we'll get? We'll get del del x of twice x divided by x square plus y square plus z square, then del del y of twice y divided by x square plus y square plus z square, and then del del z of twice z divided by x square plus y square plus z square. Okay, so now we have to differentiate it in the form of u by v. So it will be how much? This is u, this is v. So formula is what? v into derivative of twice x is x, minus then u into derivative of v. So ddx of v is what? Derivative of v is again twice x, whole thing divided by v square. So it's x square plus y square plus z square whole square. Similarly, you write the other two term. So second one will be, so now see, from all the in each and every term we will get this term common, means 2 into x square plus y square plus z square. So what we have? So when we add all the term, it will be 6 into x square plus y square plus z square, and then in the first term we have minus 4x square. In the second term you will get minus 4y square. In the third term you will get minus 4z square. So if we take 4 common, it will be x square plus y square plus z square, whole thing divided by x square plus y square plus z square what? Whole square. Now what we have in the numerator, we see 6 minus 4, so it will be 2 into x square plus y square plus z square, then divided by x square plus y square plus z square whole square. So 1 x square plus y square plus z square can cancel out. So our final answer is 2 divided by x square plus y square plus z square. So the problem is a little bit lengthy, but it's very simple. Okay, now let us see to this fourth problem. So what to find? Divergence of r to the power n, and then with this one r bar is there, and the value will be n plus 3 into what? N plus 3 into r to the power n. Okay, so let us suppose that our r bar is like this: x I cap, y j cap plus z k cap. So then we know that what is r square? R square is r dot r. So it will be x square plus y square plus z square. One similar type of problem we already did in gradient. So now if we differentiate this this particular equation with respect to x, then we will get partial with respect to x. Then derivative of r square is twice r del r by del x. On the right hand side you will get twice x. So this implies del r by del x will be equals to x by r. Similarly, del r by del y will be your y by r, and then del r by del z will be your what? Z by r. Okay, this thing you will get. Now let us find divergence of r to the power n, and then into r bar. So this is equals to, divergence means what? Nebula dot r to the power n, and then r bar. Now you see one thing, this is not a vector quantity. Okay, so when you talk about nebula dot, so this dot is with r bar. So you can write it like this also, r to the power n r bar. Like this also you can write. So this is equals to nebula dot r to the power n, and then what is r bar? R bar is x I cap y j cap plus z k cap. Okay, so nebula is I del del x plus j del del y k del del z dot. This will be our if we multiply this, x r to the power n I cap y r to the power n j cap z r to the power n k cap. Now we'll take the dot product. So this is equals to, when you take the dot product, it will be del del x of what? X r to the power, sorry, x r to the power n plus del del y of y r to the power n, and then del del z of z r to the power n, right? So we have to differentiate this in the form of u into v. So suppose first x, derivative of x is how much? 1, and then r to the power n will be there, and then if we keep x outside, now what is the derivative of r to the power n? It will be n into r to the power n minus 1, and then del r by del x. Okay, similarly you write for y and then for z, similar type of term we will get. So r to the power n plus x n r to the power n minus 1, and this del x by del r. Del x by del r is how much? It is x by r. Okay, so other two terms kindly fill up. So what we will have? R to the power n plus n into, see, x into x is x square, and then this r into r to the power, this means was r to the power n minus 2. Similarly here you will get r to the power n y square r to the power n minus 2 plus r to the power n z square r to the power n minus 2. Now if you add all the term, there are 3 r to the power n. So r to the power n, r to the power n, r to the power n is 3 r to the power n. And from the remaining term, if we take r n to the power n minus 2 common, we will get x square plus y square plus what? Z square. So 3r to the power n into r to the power n minus 2, and x square plus y square plus z square is again r square. So what we have now? 3r to the power n plus n into again r to the power n. So if we take r to the power n common, so it is 3 plus n into r to the power n. So this is the answer. Now let us move to the problem number 5. So this problem is a little bit important. You see r bar cross a bar cross b bar. So this is nothing but vector triple product. So in vector triple product, what is the formula? B dot r bar, b bar dot r bar. So there is one lecture on vector triple product. So if you haven't gone through it and you go through it, then you'll understand. It's very simple. So b dot r into a bar minus b dot a into r bar. So this is the formula for vector triple product. Now we know that vector dot product is commutative. So b dot r, we can write r dot b a bar, and then this we can write a dot b r bar. Okay, now let us suppose that r bar is equals to x I cap plus y j cap plus z k cap, and b bar we can choose like this: b1 I cap plus b2 j cap, and then what? b3 k cap. So what will be r bar dot b bar? So it's x b1 plus y b2. This we need in the later calculation. That's why I'm writing here z b3. Okay. Now what we have to do? We have to find divergence of this. So divergence of r bar cross a bar cross b bar. So it's nothing but nebula dot. So this is how much? R dot b into a bar minus a dot b into r bar. Okay, so this is equals to nebula dot, this value we know na, r dot b. R dot b is how much? It's x b1 plus y b2 plus z b3 into a bar. Okay, so I'm writing this term first, this into this dot this. So it's nebula dot, I'm writing the value of r bar dot b bar here, and a bar will be as it is, minus, now see, this is a scalar quantity. A bar dot b bar is a scalar quantity. So this scalar quantity you can keep outside. And then what we'll write? Nebula and then r bar. So it will be nebula dot r bar. Okay, nebula dot r bar. Now let us calculate it. So this is equals to nebula means what? I del del x plus j del del y, I del del x, j del del y, k del del z. Okay, dot. Then it is how much? X b1, y b2, z b3, then a bar, and the last term, no, a bar dot b bar. You see in example number 2 you already did it. Nebula dot r bar is how much? 3 into 3. Now here the first term is interesting. This dot, no, this dot will be with a bar because a bar is a vector quantity. This is not a vector quantity. So what we'll do, we'll operate this with this one first and take the dot product with a bar. So if we differentiate it, what we'll get? See, I cap is I into del del x of x b1. Del del x of x b1 is how much? Only b1, and other term will 0 because there is no x. Then j into del del y of this whole term, del del y. So here we see only y. So derivative of y is 1. So you'll get how much? b2, and then similarly k into how much? b3. Okay. Now this dot, no, this particular dot we'll write here dot, and what is in the last? A bar. And this is 3 into a bar dot b bar. Now see what is this one? I b1, I j b2. This is nothing but b bar. So b bar dot a bar minus 3 into a bar dot b bar. Okay. So a dot b and b dot a is same. 3 into a bar dot b bar. Okay. So if you subtract it, you will get minus 2 into a bar dot b bar. This is the example. This is the answer. So let us take one last problem. Divergence of gradient of b. So it's a very simple problem. Divergence means nebula dot grade v. Grade v is what? Nebula v. So this is nothing but I del del x plus j del del y plus k del del z dot nebula means grade phi is what? I del v by del x plus j del v by del y, and then what? K del v by del z. So now if you do the dot product, what you will get? You will get del del x of del v by del x, del del y of del v by del y, and then del del z of del v by del z. So this is nothing but del square v by del x square, del square v by del y square, and then del square v by del z square. So this one, no, this we can write nebula square v. This is called Laplacian operator. Okay. So there are more problems. So if I get time, then I'll make one lectures on this gradient, or else we'll make one combined lecture where we can do gradient, divergence and curl problems on the later part. So thank you for watching, and kindly subscribe and share with your friends.